Okay, so this is the first video for the Maps project, and I've got dot maps opened here. We'll do these other ones, choropleths and the Montana election next. Let me slide this out of the way a little bit. Our main mapping package is this leaflet, and so when I run that, it's this leaflet here that allows us to create the maps. And I'll just do a real simple map to start. We're going to start with the leaflet, and then we'll use this add tiles. Add tiles, the tiles are really just the little pictures that we expect, like what the country looks like, or it could be the names of the streets or whatever. Now this is so simple that it's kind of ridiculous. In fact, it does this weird thing where it repeats, but you can just see, you can kind of zoom in, just like with Google Maps or something else, and you can start to get the names of the cities and states and stuff like that. So that's the most basic way that we'll use it. And one of the things that I wanted to show you to start out with is that if we can put a dot in. And so it has some explanation here of there's this system for the coordinates of a location that uses degrees and minutes and seconds. And so if you look up Billings here, it says 45 degrees, 47 minutes, 12 seconds north, and then 108 degrees, etc., west. And the problem with that is that we need to convert that from that degrees, minutes, seconds system to decimal system. And so I kind of just talked a little bit about how you would do that. I mean, basically, let me add this in here. You know, let's say if you start out with 45 degrees, that'll stay the same. But 47, it's not 47 out of 100, it's 47 out of 60. So you have to do 47 divided by 60. And then, so it's this 0.7833. And then for the seconds, it's, you know, okay, so now there's 60 minutes in an hour, but there's 60 seconds in a minute, so we really have to calculate that. We need to do 12 divided by, and then it's 60 times 60, so 30,600. And so to convert, we would have to make that 47 degrees 12 seconds into, we have to add these, so it's 0.7866, I guess. And so let me delete this here. But I think when I did it, I just kind of estimated it. There's the 0.78, and then I said I just kind of rounded up to 0.8. So that's a little off. But if you wanted to be more exact, you know, you could do that math the way I did it. Here's the other thing. When you have, let's see, this 108 degrees west, that's like the x-axis, west-east, and if it's west, that's actually negative, right? That's into the negative territory. So when you convert it to decimal, there's no way to put west or east in there, so you just have to make it negative or positive. And so if it was 45 degrees south, it would be negative. In our case, it's 45 degrees north, so it's positive. So anyway, you can kind of read about that, but basically what we want to do here is yeah, I think I can just copy this and add it like that. And so I did this this conversion, approximate conversion from this degrees, minutes, seconds system. This is for Billings, and then I set a zoom level of 11. And then you'll see that what that'll do is it says set view, so it'll center it on Billings. And so there you can, you know, kind of zoom in and scroll around and all that kind of stuff. Just to show you, if we set it as a zoom level of, let's say, 8 maybe, you know, so that's more like at about the state level. Etc. You could mess around with that. Okay, so set view, we're finding a location to start on and then a zoom level to start with. The other thing we can do is we can it says we can add a location marker, and we can use this add markers or add circle markers. And so if we do that for Billings, we can add this line, just basically similar to what we did above, but add markers instead of set view. And when we do that, it'll put like that little standard marker that you see on maps right on Billings. Now, if you look up Bozeman, and I think I just looked it up here, so if you look up Bozeman, 45, 40, 40, yeah, and then 111 degrees west, so remember that's got to be negative. So basically what I wanted you to do is to convert that. So maybe I'll be a little bit more accurate with this one. So if we do 40 divided by 60, and then we do 40 divided by, and then 60 times 60 for the seconds, because it's 40, 40. And so that would give, and I said put my answer here, so that would be 45 degrees point, let's see, it's 677. And then for the, let's see, west, it's 111 and then 250. So 111 is going to stay, but I'll just replace that 40 with a 2, and then the next 40 with a 50. Let's see what we get. And so that's going to be, what did I say, 111. So it's going to be negative, because it's west. And then point, what is that, 0.46. I'm adding that up right, something like that. And so then it says add a second add markers for Bozeman. So I'll do add markers, and then latitude equals 45.677, longitude equals negative 111, because it's further west, right? So instead of negative 1, we're about at the same latitude, about 45. But then the longitude is, Bozeman is further west, so we're going more negative 0.046. So let's run that. And there you go with the two location markers. And notice that I did not use set view there. If you have some location markers, Leaflet will automatically kind of center you into the markers that you've set, and then zoom it up appropriately. Now that would be a little bit of a pain to sit there and enter in. Let's say you have a whole bunch of these things, and so you can take a data set that already has latitude and longitude like this, and Leaflet will plot all of them. And so there's this Socrata website, and you can go check that out, but it has a bunch of data like from cities. I noticed a bunch of police data. Billings unfortunately didn't have one, but one of the close cities that I saw that had a data set was this Colorado Springs. And so basically what I did is this is the link here to that spreadsheet, and you can go and look at that, but we'll go ahead and bring that into R with this. And I noticed I got a few errors here, but it seems to work anyway. So I'm not quite sure what the errors were, but it seems to work. And it has a whole bunch of crime incident reports over, it's over many years. And in fact, it's too big to map all of it. And so what I wanted us to do is just to pick one year, and this was I just picked this year, 2016. And so what this is doing is it's finding it's called incident date time. In fact, let's go ahead and look at this data set. You can just see it's got incident ID. It has when it happened. You know, this happened at 4:29 a.m. on September 25th, 2015, and this is driving under restraint. and then so it has a description of what happened, the address, and then there's the latitude and longitude that we're going to use to plot where the crimes happened, zip code, etc. Day of the week, all kinds of other stuff. But what we're going to do is take that, let's see, this incident date time here, and then extract the year. So we're going to focus on 2016 and then filter it for that year. And so that's what this does. And then it calls it a new name. It calls it Colorado Springs Crime 2016. And so we'll do this because this will be a little bit smaller than that massive data set from all those years. So what we can do is we can start out with the data set and pipe that into Leaflet and just do add tiles, and then let's do that first. You can see it doesn't do anything right now. So what we need to do is pipe, and I'm going to use, instead of add markers, I'm going to use add circle markers. And then we actually don't need to do anything, and it's kind of cool because Leaflet will automatically find the latitude and longitude and then plot them. And then remember, it will center them in the location that you're using. So there you can see that's what the little circle markers look like. It's kind of a, it's kind of a circle with a border around it, and there it shows where the locations. I assume the police just have a little button in their patrol car that they can press, and it'll automatically record the GPS location for the crime. So you can kind of see, if you're familiar at all with Colorado Springs, you can kind of see where, I guess, where to stay away from, where most of the crimes are, and yeah. And so what I said is that I didn't really like the looks of the circle markers with the big heavy line around it. So I'm going to modify that a little bit, make them look a little better, in my opinion. And it says inside the add circle markers, parentheses, add in stroke equals false, and so that'll get rid of the kind of the border around the circle. I'm going to make them a little transparent because they're overlapping, and so I'll make them 0.6, and I just kind of played around with these numbers until it looked decent to me. And then radius, I'm making them a little smaller. I think they're a little too big. So let's take a look at what that looks like now. So I think that looks a little nicer, a little transparency, a little smaller, The other thing you can do is you can create a little pop-up. So I'm gonna, let's see, let's go back here and copy this again. And so what I want to do is inside of add circle markers, in fact, I think what I'll do is I'll start to indent here so it looks a little neater, since I'm going to put some more stuff in here. And I'm going to add pop-up equals, and then this squiggle, and then address 1. And so what that will do is well, let's just run it and I'll show you. So now if I click on one, it'll give me the address. And you could do anything, you could put what type of crime it was or something else, but I just did the address. Okay. Yeah, and so I think the next part, it says go ahead and do that again, but this time put a description of the crime. There's actually a couple of them. It says incident type primary, incident description. Yeah, let's use this incident. It looks like it's the same. At least in every case I'm seeing here, it looks like it's the same. Third-degree assault, non-family strong arm. So let's just put incident description in there rather than address 1. And then do that again. And so now when I click on it, it shows what type of crime it was. There's a lot of crimes right in this area here. Okay. Oh, and then so I say another option is to use label. So I say replace the word pop-up with the word label, and what that will do is you won't have to click on it. Just when you just kind of hover over it, it'll pop up the oh, in this case I'm still doing the address, yeah, but incident description or whatever you want to put in there. Okay, so label or pop-up. Now I wanted to show you that you can also map tweets, and so I made sure before starting this video that I had my keys and everything working, so you probably need to make sure that you do that. And then what I did here is you can set a geocode. So in this case, that's the Billings, GPS coordinates, and I set it for a 20-mile radius around that center point, and I'm collecting 10,000 tweets, and I'm collecting that many because most people do not put their coordinates in their tweets, but it is possible to do that. You'll see people go into a restaurant or something, and then indicate that's where they are. And then, okay, so I called this BL tweets for Billings, and then there's this function called lat longe here, and what you need to run that as well. And what that will do is it'll take those coordinates if they're in the tweet, which again most people won't have them, but if they are there, it will convert them to something that that R can understand as latitude and longitude. And so what we can do here is we're going to start with this BL tweets, and then we're going to go to leaflet, and then add tiles. This is kind of what we've done before. And then we're going to use add circle markers like we did before. And then and so what it should do here, let me see, let's go to this data set here. And okay, so there's all of these tweets. Let's see if we can find the latitude and longitude. No, that's language. Maybe it's at the very end. Oh, did I miss it in here? Why am I not seeing that? Let me try. Let's see. Let's do this. Let's do glimpse and then BL tweets. Oh, there it is. Yeah, right there at the end, latitude and longitude. And so you see a bunch of NAs. That means those people didn't include it, but some people did, right? And so, okay, let's actually get rid of that. What else did it want me to do? Oh, and then it want me to use pop-up equals, and then the text, which is the text of the tweet. Okay, so let's see if that works. Okay, so there you can see, it's a lot more sparse than our crime data, but again, these are the people, the people that put their location in their tweets in Billings. And so there's one for a job. I've done this before and noticed that there's a lot of like job ads and stuff like that. But there's someone who just whatever their own tweet was. A bunch of these downtown. Yeah, more like jobs. I don't know what that is. Anyway, you get the idea. So, no, that was I think that's the National Weather Service right there. That's where that location is. So it just kind of tweets out the weather all the time. kind of creepy actually, because you can like get pretty pretty close to the exact location. Like here's somebody. This looks like it's somebody's residential. You could go knock on their door. Did you tweet this? Don't do that. Um, so it says here, when you're doing that with Billings, choose another location. And so let's go back here. Yeah, let's take this. I'm just going to copy it. And so I'll show you one thing you can do is if you go to Google Maps, let's say, oh, let's go down. Let's go. I used to live in Ohio, so let's go to Cincinnati, Ohio. And I used to live right around here somewhere. So I think if you there we go. And so there you can see it gives you the location. Oh yeah, here. And so now, so what's nice about this is it gives you it in decimal, it gives you in both. And so what I'm going to do is copy the decimal version of the location, and then come back here. And so I'm going to call that CN tweets, and I'm going to replace that with this. I have noticed that it doesn't like any spaces between the commas in here. Like if you do that, it won't work, which is kind of ridiculous. But just be careful about that. Make sure you don't have any spaces inside of the quotes here. And then I'm gonna call this CN tweets, and let's run that. Now, while that's working, let's go ahead and I'm going to use this to map them, but I'm just going to change it to CN tweets for Cincinnati. Let's see, is that working? Yeah. Okay, rate limit exceeded, so I'm trying to do this, I'm trying to collect too many tweets, but it's still got 5,000. So let's run that. Oops. Oh, I got the latitude and longitude of the Billings tweets and not the Cincinnati tweets. Let me run just this one part again. Okay, let's see if that works. It should be Cincinnati and not Billings. There we go. No? what am I doing here? CN tweets. Did I mess it up somehow? Let's run this again. Oh, it's not going to let me do it. Oh, okay. Well, because I ran out of I can't get these tweets again, but you get the idea. Sorry about that. I kind of messed it up there. I don't think there's anything I can do to fix it now because I've already screwed this up, right? Yeah, because it set it back to 0, and now it's not letting me collect anymore because you can only collect so many in a short period of time. Anyway, you get the idea. Just make sure that you don't do what I did. Make sure you whatever you call this, that you change it everywhere you need to change it. I left this as BL tweets, and that's why it didn't work. Okay, so the next data set is it's actually a kind of sad but interesting article about mass shootings in the U.S. And it's this Mother Jones magazine, which I don't know much about, but I just know that they had a decent a data set and discussion of the of mass shootings in the U.S. And you can go to their spreadsheet here, and it just, in fact, let's go ahead and do it. it basically it has collected over time all in this Google Docs spreadsheet the mass shootings that have occurred according to certain criteria since I think it was 1982 was this first one, and it has a bunch of data on each one. So what we're going to do is basically grab this spreadsheet, put it into R, and then do some analyses on it. And the way I did that is if you add this export format equals CSV to the end of a Google spreadsheet, you can use this read CSV. So you're basically making Google convert it to a CSV and then reading it like that. And so it says use glimpse. And then I called it shootings, and you can just see all of the variables that it has: gender and race of the shooter, the number of fatalities, where was the weapon obtained, all kinds of stuff like that. And one of the things it has is the latitude and longitude, so the location of the shooting. Okay, and then it says create a data table, so we're going to start with shootings, send that to data table, and sorry, before we do that, we're going to use this select, and we're going to select the name of the case, the location, which is like this city that it's in, the date, just kind of some information, the number of fatalities, total victims, and age of shooter. So we're just going to select a few of these variables, pipe it into data table. What happened here? Oh, data. That should have been date. Okay, let's try that again. Okay, so there you have a table that you can sort on these things. Wow, 11-year-old. Sort on the number of victims and stuff like that. And it says we can look at some basic statistics, so we're going to use count, start with shootings, and then count, and then it says prior signs of mental health issues. And so that'll show how many individuals had mental health problems. And there's some weird categories in here. So I wanted to kind of clean this up a little bit, and so we're just a little bit of a review. I think it was the Pew dataset, and we changed some of these things with this factor collapse. So anything that was kind of an unknown, like TBD or unclear or unknown, we're going to collapse those together with this command. So I have all the code out here for you, but I just thought I'd show how we did that from before. So now we have yes and sort of unknown or unclear and then no. And so you can see most of them did have some prior signs of mental health issues. This creates a histogram of the number of fatalities per incident. So you can see that there were some that were, 55 to 59, so somewhere around there. Most of them were more like between 5 and 10, but some of them were very high. I'm going to copy this because it says to create another histogram of the age of the shooter. So I'm going to do age of shooter. And there you can see it's kind of interesting, almost bimodal. So a lot from 25 to 29, and then again a lot from 40 to 44. And then this will find the median age of the shooter, which I assume without looking at it that it should be around 30, right? Maybe a little higher, 35. And so there 34.5 is the overall median age. And then finally, again, this is kind of review, but we can do a heat map. Oops, I don't know what I did there. And we're going to use this Plotly. And then x equals age of shooter. and y equals the race of the shooter. And then we're going to do add histogram 2D or 2D contour. And yeah, I think that's all we need. And so again, we had this problem where they spelled white with a capital and a lowercase, and so it treats them as two categories, like a couple of these other groups. But you can kind of see the most common age. There's that bimodal where you have kind of in the 20s and then in the 40s, and then you see mostly white. And we probably should go back and collapse these, but I won't bother to do that now. Because what I wanted to get into is using a linear regression to do some hypothesis testing. And I'm going to have you do a different one, but the one that I wanted to look at in the example here was this question: has the number of fatalities per incident increased over time? And the reason that I wanted to look at that is you'll sometimes hear that the number of people that are killed in a mass shooting has increased because of the types of guns that people are using. Larger, number of bullets that people can shoot in a short period of time. And so I thought I would look at that since that the information is in this data set. And so the first thing I want to do is create the data set. So I'm going to call it fatalities data, and basically what I'm going to do here is start with the shootings. I'm going to group by year because that'll be my time measure that we're using, and then I'm going to do a summary that has the count, so the number of shootings per year and then the number of fatalities, and then create a new variable for fatalities divided by count. So that's the number of shootings per the number of fatalities per shooting, and then show that. And so you can see in 1980, well, let's say 1993, there were 4 shootings and 23 fatalities total, which leads to 5.75 fatalities per incident on average. And so this is the key number here, and has this increased over time? You have 8 and 14 and 15, and and we probably don't want 2019 yet. Oh well, we'll leave it there. And so the other thing I wanted to say is that if you read the article, it says that they changed the criteria in 2013 from a minimum of 3 to a minimum of from a minimum of 4 to a minimum of 3 after 2013. And so there's a change in the way that they sort of decided whether to include a shooting. And so I want to add this filter command in there. So what I want to do is just take this again, copy it, and then I'm going to take this, and stick it in there. So I'm going to filter. Let's see, I guess it doesn't matter, right in there somewhere. Oops. I think that's what I want to do. Okay, so then we run it again. And so like if you look here, let's see if we can find one. So in 2018 there were 12, in 2017 there were 11. Let's see if that remained the same. Yeah, so you can see it's reduced now. Instead of 11 and 12 in 2017 and 2018, and there were 3 in 2019, it's reduced that because the criteria were expanded, and so that will keep it consistent with previous years. So anyway, just make sure you run this, and that will set up your data correctly to do this kind of analysis. So to create the regression model, we're going to use this LM, and the format is kind of funny. So it's basically LM, and then whatever your y variable is, and then squiggle, and then the x variable, and then the data. And then we're going to call that whatever we want to call our model. So LM, whatever your y variable is, and the y variable is the outcome variable. It's what we're trying to predict. So in this case, it's going to be the number of fatalities per incident. The x variable is going to be the year. It always seems a little backwards to me because it's like, okay, X causes Y, but we're putting Y first, and then the data. So we can just run this, and all we've done there is put this linear model, this LM, into this fatalities per incident model. And if we print out the model, it doesn't tell us much. It actually gives us the equation for a line. If you remember from algebra, we could do, basically it's going to be, well, it says here, so y equals 0.0399x plus negative 71.608. And so that's what we're going to get to, that's the regression line. But it's not that informative otherwise. There's not much we can do with that, and so we can use this tidy and glance to get some information. That's from the Broom package, and that'll give us some more useful statistical information. So one thing that's useful is the R squared, and so this shows us it's not very good. This R squared is very low. The maximum R squared is 1, and so this is 0.01. It's pretty small. And this has, it has a p-value, the statistical significance of of year for predicting the number of fatalities, and you can see we're looking for something less than 0.05, and it's 0.5. And so it looks like the hypothesis was not supported by these data. Yeah, and so you can read that part. Yeah. So this will create a scatter plot of the data with Plotly, and there you can see, this is the fatalities per incident, and there is this big one here. I wonder if that was that Vegas shooting, but that was the highest, and that was late. But there are also some high ones back here in the 1980s, and a few that were, to me, if anything, it kind of seems, I don't know, kind of curvilinear. It was high in the 80s and high today, but not so much in the around 2000. So now what we want to do is put the regression line on the map, or on the plot rather. So I'm going to take this, copy that, and I want to run this again, but I'm going to add this line here, and it says add lines, and it's a little bit funny formatting, but basically we say add lines y equals fitted and then the name of our model here, and that'll extract that intercept and slope here out of it and plot it as a line. So let's go ahead and pipe that in, and there we go. So you can see that line is pretty flat, which indicates that it's not, the number of fatalities has not really been increasing. And we can clean it up a little bit. I'm going to copy it again. Notice that there's this weird trace 0 and trace 1, which we don't want that. And there's some other things we can do to make it look a little better. So I'm going to paste this here. And so it says add show legend equals false inside of add markers. Show legend equals false. We're going to add a new line with layout. Let's put this at the end. So we're going to say layout, and then I think I'm just going to copy this stuff here. Yeah, just some labels for the x-axis. Let's indent that a little bit, and then we can have this pop-up come up, and I'm going to do something that's a little bit more tricky here with this hover info, and we have to put that inside of Plotly. Let's create a new line. Let's indent this a little bit. Let's see. Do that. and that, I guess. And what this will do is it'll paste, so meaning it'll put into the pop-up, it'll say fatalities per shooting and then have this variable appear, and then this BR breaks, so it'll be a return. Well, let's just let you take a look at it. So now when I hover over it, ooh, I should probably round that too. Let's actually run that again. Let me try something here. If I let's do round fatalities per incident and then to 1 maybe digit. Let's see if that works better. Yeah, there we go. So instead of 11.666667. Okay, I think that's it. All right, so our first hypothesis that the number of fatalities per incident increased over the years is not true. I'm going to have you, for your assignment, create your notebook and focus on this shootings data. And what I want you to test is this hypothesis that the number of shootings per year has increased. And so this is the code that you'll need to use to look at that. So you'll need to copy and paste this or recreate this in your notebook, and then test that with another regression model. All right.